What's up, everyone, and welcome. In this episode, we are going to talk about the Azurescape Kubernetes attack, which allows cross-account container takeover.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
A critical security vulnerability allowing attackers to perform cross-account container takeover in Microsoft's public cloud, dubbed Azurescape, has been uncovered by researchers. The issue exists in Azure Container Instances, otherwise known as ACI, which is Microsoft's container as a service offering, which enables users to run cloud containers without having to deal with managing the underlying infrastructure of Kubernetes. Part of the infrastructure hosting ACI consists of multi-tenant Kubernetes clusters. Now, you can think of multi-tenant like a shared hoster. You know, if you think back to when you were paying $8 a month for hosting, but it was on a shared server, you had multiple customers that had their stuff on there, and there were virtual or digital walls between each customer's stuff. Now, multi-tenant Kubernetes clusters can be compromised to allow cyberattackers to gain full control over other users' containers, researchers from Palo Alto Networks Unit 42 team explained. A malicious Azure user could have exploited these issues to execute code on other users' containers, stealing customer secrets and images deployed to the platform, and possibly abuse ACI's infrastructure for cryptomining, they said.
Forgive me, my friend. Do you like blackberry pie? No. Did you say blackberry pie? Yummy. We'll have some.
Microsoft has rolled out a patch to ACI, but users should revoke any privileged credentials that were deployed to the platform before August 31st to avoid compromise. They should also review access logs for any irregularities, Unit 42 recommended. In the multi-tenant architecture, each customer's container is hosted in a Kubernetes pod on a dedicated single-tenant node virtual machine, according to the analysis, and the boundaries between customers are enforced by this node-per-tenant structure. Since practically anyone can deploy a container to the platform, ACI must ensure that malicious containers cannot disrupt, leak information, execute code, or otherwise affect other customers' containers, explain researchers. These are often called cross-account or cross-tenant attacks. The Azurescape version of such an attack has two prongs. First, malicious Azure customers or adversaries must escape their container. Then, they must acquire a privileged Kubernetes service account token that can be used to take over the Kubernetes API server. The API server provides the front end for a cluster's shared state, through which all of the nodes interact, and it's responsible for processing commands within each node by interacting with kubelets. Each node has its own kubelet, which is the primary node agent that handles all tasks for that specific node. Thus, the end result of an API server compromise is establishing complete control over the multi-tenant cluster and all customer containers running within it, according to Unit 42. So again, thinking back to a virtual hoster, you have different websites or different applications on the same server with this digital wall, and taking control of the higher mechanism or the server above it gives you actually control and access to all of the customer's stuff.
Now's my chance to try my psychological experiment. You are in my power. You are slowly going into a trance. You are getting sleepy. You are completely under my control.
The first step in the attack proved easier than expected. Unit 42 researchers found that Azure uses runC, which is the industry standard for container runtime, to power ACI. Unfortunately, this happens to be an ancient version of the technology, runC 1.0.0-RC2, which was released way back in 2016. True to legacy software form, it harbors at least two container escape bugs. Unit 42 researchers went on to use one of these, which is CVE 2019-5736, to break out of a test ACI container, gaining a reverse shell running as root on the underlying Kubernetes node. While we escaped our container, we were still within the tenant boundary, the node VM, researchers explained. CaaS platforms are designed to withstand sophisticated attackers who possess kernel vulnerabilities, enabling privilege escalation and container breakout. A malicious container breakout is a somewhat expected threat. It's tolerated through node level isolation. So it's a known attack. It happens, but through the node level isolation, breaking out of the container, you are still within the boundaries of the permissions and limitations of that particular node. Escaping this underlying node VM, the boundary with other customers, means, or the wall between customer A and customer B, means finding a way to access the API server, which the server, the software or server that sits above all of these nodes and controls them individually in sort of a silo mode. The best way to do this is by obtaining a privileged access token for the API server, the researchers soon discovered. In hunting for a way to obtain such privileges, researchers observed that ACI supports executing node VM commands on uploaded containers via the AZ container execute command to a kubelet, which is handled by a dedicated bridge rather than the API server. Now, researchers said that the implementation of this bridge pod is a fix for previous vulnerabilities. So apparently maybe there was a vulnerability in the actual API server itself for when you upload a container and run commands on the container. So they implemented a pod to sit between the API and the functions for that are processed when you upload a container and run commands on it, so that pod could fix a vulnerability that may have occurred when you speak directly with the API. But that pod comes with an issue. Curiously, researchers found that such execute requests arriving at the node included an authorization header, which carried the Kubernetes service account token. So there is their token. Now, the token was for this bridge service account, but finding a token here was surprising. According to the analysis, kubelets in the cluster were configured to allow anonymous access. So there's no need for requests to authenticate via a token. And they say perhaps this was a relic of some older implementation. Now, researchers then examined the token's permissions and found that it could be used to execute commands on any pod in the cluster, including the API server pod. So this token wasn't just for that bridge pod. Actually, the token's permissions allowed it to execute commands across the entire infrastructure.
Focus! Focus! Now I crush you!
Abracadabra!
Focus! Focus!
Abracadabra!
Focus! Focus!
Abracadabra!
So from there, exploitation was straightforward, they said, and they were quickly successful in using the token to open a shell on the API server container as a cluster administrator with full control over the multi-tenant cluster and all customer containers within it. If you run Kubernetes, be careful to whom you send your service account tokens. Anyone who receives a token is free to use it and masquerade as its owner, researchers noted. Token thieves are likely to be very interested in the permissions of their stolen tokens. In short, the Azurescape exploit worked like this. Deploy an image exploiting CVE 2019-5736 to ACI. The malicious image breaks out upon execution and establishes code execution on the underlying node. On the node, monitor traffic on the kubelet port 10250 and wait for a request that includes a JWT token in the authorization header. Issue an AZ container execution command to run a command on the uploaded container. The bridge pod will now send an execute request to the kubelet on the compromised node, and on the node, extract the bridge token from the request's authorization header and use it to open a shell on the API server. The fix was simple. Microsoft merely ensured that the bridge pod no longer sends its service account token to nodes when issuing execute requests. Again, the researcher said there's no need for a token because any anonymous person can deploy a pod, so there's no reason for the token to be there. Azurescape may be mitigated, but there are likely other avenues to achieve this kind of exploitation, Unit 42 researchers warned, and they're right. Cross-account vulnerabilities are often described as nightmare scenario for the public cloud. They concluded Azurescape is evidence that they're more real than we'd like to think. Cloud providers invest heavily in securing their platforms, but it's inevitable that unknown zero-day vulnerabilities would exist and put customers at risk. To protect one's Kubernetes assets, users can implement the following best practices, Unit 42 advised. Keep cluster infrastructure patched. Refrain from sending privileged service account tokens to anyone but the API server to prevent attackers from masquerading as the token owner. Enable the bound service account token volume feature. When a pod terminates, its token is no longer valid, minimizing the impact of token theft. Or, random tokens just sitting around forever. Deploy policy enforcers to monitor and prevent suspicious activity within clusters, especially service accounts or nodes that query the self-subject access review or self-subject rules review APIs for their permissions. So, what did we learn? Azure was using an outdated version of Run C, which was released in 2016, to power its Azure Container Instances, also known as ACI. This legacy version had 2 container escape bugs, allowing the researchers to break out of their own Kubernetes environment and gaining a reverse shell running as root on the underlying Kubernetes node. Access of the API server was achieved by capturing Kubernetes account tokens carried in an authorization header for some previously patched bridge pod. This token allowed them to gain root access or shell access to the API server and basically send commands to any pod in the cluster, including the API server itself. So, what should we do? Well, I just gave you the advised remediation steps from Unit 42, but users should also revoke any privileged credentials that were deployed to the platform before August 31st to avoid compromise, and 100% you should be reviewing your access logs for any irregularities immediately to see whether or not, even though there's no known attack or in the wild, this could certainly be under the radar and somebody could have access to your system, so it's best to check your logs immediately. With that, I say thanks for watching, don't forget to share, and subscribe if you haven't already, and smash the bell if you haven't already, and I'll see you on the next episode. Take care.
Don't forget to ride. Farewell.